Hello, thank you for joining us today on our webinar, Equipment Health Monitoring for Predictive Maintenance. This presentation will be recorded and posted on the Lesman website. My name is Jim Haldeman of the Lesman Instrument Company, and I will be your host. Today's presenters are Vern Smith, who is the Business Development Manager for Honeywell Process Measurement and Control. Vern has 10 years of experience as a turbine control systems engineer, where he specialized in condition monitoring of rotating machinery. Vern has a bachelor's degree in electrical engineering from the University of Pittsburgh. Owais Arshad is the manager of field instruments at Honeywell Process Measurement. Owais has over 16 years of experience in process instrumentation and has been involved in product development for a variety of process instruments. I will be monitoring the chat room for questions that may be asked. So if you have one, please enter it there and I will ask the question on your behalf. Everyone's mics will be muted. If there are any additional questions, we can address those at the end of the presentation. I will now give the presentation to Owais. Owais, please show your screen and begin your presentation.
Okay, thank you, Jim. Much appreciated. Once again, my name is Owais Arshad. I'm a global offering manager for process measurement and control. We'll get started today. So today, the agenda today, basically, I want to kind of explain what is EHM, why we feel like it's needed, give you a quick overview of some key benefits for EHM. EHM standing for equipment health monitoring, and then show you a quick look at our solution, what we've have officially launched, and then a real world example, a quick roadmap of this family of products that we are looking to launch in the near future, and then also a live demonstration, and then we'll open up the floor for Q&A. So what is EHM? So it's the monitoring of key process or key parameters of an asset during normal operation, and utilizing that data to help get into the realm of being preventative and predictive and even prescriptive maintenance strategies. So that is in essence, in one sentence, what EHM is. So why is it needed? We are trying to get our end users into a spot where to be in the predictive realm, because we find that that's probably going to be where your lowest overall cost is going to come in. Usually your most expensive is at the very front end when you first have invested, and at the very end where you've run this asset till it breaks. So you're having to buy a new one. So in the interim, if you can do things to help maintain that asset much better, that is really where we're trying to target our solution. And when we launched this project, we did just sit down with the various customers, and they did express to us, what their needs were. They want to maximize, their reliability and the availability of their assets, and they really wanted to just reduce their scheduled downtime and really eliminate any unscheduled downtime. They really want to be in that predictive realm. We want to help them get there, obviously. So in turn, that was going to help them operate more sustainably and reduce any manual intervention and overall reduce CapEx.
Really hard to be so non-reactive without all of the data that this thing offers, in my opinion.
Thank you, Vernon. Benefits of EHM. So in a nutshell, if you were to just come into a company and ask them, about their assets, over 69% of them, don't know when their assets are due for an upgrade. They don't always know when it's time to schedule maintenance, or when the asset itself should be replaced. When should they, just flat out stop working on it. So with this type of product, and in the realm of, how IoT devices can be predictive, they basically what you can help do is reduce that unplanned downtime up to 80%, and in turn, the data that a device is providing can help you just overall decrease your planning time for maintenance. Just because you're relying on something that's providing you reliable data about your asset. You're obviously going to increase your equipment's uptime and then reduce overall maintenance costs. Instead of fixing large problems, you're tackling the smaller ones and keeping your asset going.
OAS, I did have a question that came in regarding data, and the question was, how is the data secured? I'm not sure if this is a good time to ask the question, but you had mentioned data, so that's why I wanted to ask.
Yeah, sure. Well, I would like to get to that data once I introduce the product, if you don't mind. But yeah, I'll definitely answer that question. Please ask it again towards the end. And how are we solving the problem? A good example with this product, before you see our overall solution, is from IEEE. If you're looking at a motor, most failures in a motor are actually mechanical. You have your rotor bars, your shaft, your bearings taking over 50% of failures that occur in motors, rotating equipment essentially. So what are some key parameters that we could monitor potentially? Not that we're monitoring all of these or not, please don't get me wrong, but just in the realm of the industry, when you're monitoring equipment health, infrared, thermography, ultrasonic, motor current, steam trap, oil analysis, and vibration. Vibration taking close to 50% of the parameter that's measured typically. And analyzed for the asset. So that's kind of the realm we're kind of delving into right now, is going to be vibration analysis with our solution. And again, mentioned briefly, rotating equipment is what we're targeting right now with this solution. So your fans, blowers, gearboxes, pumps, motors, and compressors, not necessarily tackling your most critical equipment. I don't want to tackle anything that's going to necessarily shut your plant down, but it's the thing that keeps day-to-day operations going smoothly, and it doesn't affect that could affect your production is what we want to monitor, but not necessarily something that's critical and could shut your whole plant down. And why rotating equipment? Well, typically rotating equipment actually carries certain signature faults with them as well. So the typical faults that occur in rotating equipment, the equipment mentioned on the left, basically structural looseness, unbalance, misalignment, bearing defects, lubricating needs, and effectiveness of cooling. Now, I'm not saying we're at the realm of being able to identify exactly what's wrong with the bearing yet, but we are going to get there. Right now, and I'll explain where our baseline is with our solution right now with our device once we get deeper into the device. So signatures, faults, they tend to carry particular signatures, and a good example is unbalance and a bent shaft. So unbalance, what'll happen is you'll get a frequency spike. If you're looking at the frequency spectrum, frequency over the strength of the spike, you'll get a predominant spike for unbalance, typically at 1 times the RPM. If you have a bent shaft, you'll get predominant spikes at 1 times the RPM and 2 times the RPM. And these signatures can be analyzed, and you can drive yourself down to saying this is most likely your issue, a bent shaft, or you have unbalanced issues. And, you can at least flag and say, go check that out. That could be your issue. When vibration monitoring, knowing where and how to mount, the device itself onto the asset. Location is key. So if you have a motor, let's say, for just a motor, you want to have a device mounted generally on the non-drive end and on the drive end. Fan, same thing, the driven end and the non-driven end. And so typically 2 per asset is what we're recommending. And then something unique that's very important is the axial measurement. Are you vertical, horizontal, or axial? Well, we with our solution kind of do away with that because we actually have a triaxial accelerometer within our design, and you can mount just simply vertically or perpendicularly from the top on most assets. Not on the rotating part. Usually the rotating part is encased in something, and you would be mounting the device on that casing.
Oh yes, we did have a question. I do think you answered it. The question was how many transmitters are needed for rotating equipment. So I think you answered the question was you recommend 2?
Yeah, we recommend 2, but I'm not saying that may be the only amount, but just as a quick off the cuff recommendation, minimum 2 per asset. But it does require some analysis and some visual inspection of
Right.
where your key criteria may be, where you want to make the measurements at. So it could always be more. Don't get me wrong.
Yeah, depends on the application. Typically, you're looking at matching it up with number of bearings, and that can get costly if you're looking at wired solutions. It requires an outage. It's just a tremendous effort to get that installed traditionally until now.
Thank you.
So why did we launch with vibration? Why is vibration or equipment health monitoring? Well, there's actually standards, popular standards out there that exist that kind of drive the severity of vibration and how to monitor vibration. So there are standards that you can follow. So ISO 10186-1, 10186-3. The main difference between these 2 standards is basically the power rating of your asset, and it's RPM, basically rotation per minute. So -1 is basically for 15 kilowatts or less. -3 is for greater than 15 kilowatts. Power generation of the asset. So basically what these standards outline is, what is a acceptable level of vibration. In this instances that you're seeing on the screen is velocity, millimeters per second in RMS values. So you can clearly see that there's a good area to be in, a satisfactory area to be in, a restricted area to be in, and there's damage occurring based on the measurement. And this is one of the key measurements the device does have the ability to take. So what does our solution look like? Jumping right into the overall solution from end to end, and I'll explain how we're kind of really open with this solution, and the only thing you would really need from us if you wanted, or you could go all the way with us if you wanted. So to start, on the left-hand side is our Honeywell Versatilis transmitter. This is the launch product. This is our equipment health monitor right now. And we'll discuss why we're calling it Versatilis towards the end. But the idea is that the device communicates on a protocol called LoRa protocol. What is LoRa protocol? LoRa is an off-the-shelf, it's an open protocol that exists and it stands for long range wireless. Okay, so one of the key reasons we chose the protocol is because our device is a battery powered device, and the protocol itself kind of targets battery powered devices. It's designed for low power consumption and long range communication. What's that range? Ideally, theoretically, if you read a book, it's going to tell you something like 10 kilometers. In actuality, when you're actually in an industrial environment, you can actually achieve 1 to 3 kilometers from the device to the gateway. The gateway is, and the whole, from the device, you see this red dotted line. From here, it can be all third party off the shelf. We're not saying you have to come to Honeywell from that point on. We'd like it if you came to us, that'd be great. But we're not trying to lock anyone down. You can buy a third party gateway, LoRa certified gateway. You can execute your own LoRa network server and application server, which is what's needed to basically decrypt the data that the device is sending out. So that's the main purpose of the application server. And depending on how versatile that application server is, you can then from there send that data in different formats. So the way our solution that you're seeing that we've launched with is our device, third-party LoRa gateway. You can just get a host PC. It's an on-premises solution. We're not going to the cloud. So basically on that PC, you can run 2 virtual machines. One would be for the LoRa network server and application server. The other one would be for our solution if you chose our solution. And it communicates from the application server to our solution using MQTT format, which is just a data protocol for IoT devices. And I'll jump into the details on the device, and if you're interested towards the end, we can talk more about the Honeywell protocol. But there's 2 ways to communicate to this device. LoRa is the main intent, and then the other way is Bluetooth. So Bluetooth is intended for configuration of the device, getting the device onto the LoRa network with security keys, encryptions, and such. And that app, by the way, is free. So you can, if you had an Android or Windows 10 device or Android 10 device right now in your hand, or a tablet, you could download the app for free right now and actually learn a lot about this device if you wanted. iOS is coming very soon in the near future. We're just waiting on some verifications and certifications from the Apple folks.
Well, I have a couple questions.
Yes.
The first one is, do I need internet access to operate?
No,
this?
you don't. You just need a Bluetooth connection if you're trying to configure it for the first time. So, I guess your cellular service or internet just for that first time when you're getting it onto the network. Once it's on the LoRa network and you've linked the device, it's a closed system after that. So my solution that I have running live here is basically I have my device sitting on a motor. There's a little blue box, our LoRa gateway, and through Ethernet, it's connected to my host PC. It's a closed system. That PC has no internet access. So you don't necessarily need internet access.
Awesome. And then another question I had, you'd mentioned battery, and someone asked how long the battery lasts, how do you turn it on and off, and is it rechargeable?
Good questions. I'll answer all those hopefully in the next slide.
Awesome.
So what is our device? Let's kind of home in on the device. What have we launched with? This device right now measures all 6 parameters at once. Vibration on 3 axes, acoustics, ambient and service temperature, ambient pressure, and humidity. Okay, all those parameters are available right now in the device. You don't have to select them or anything like that. You're going to get them all. You have the ability to turn them off if you don't need the measurement, but they're all there. It's a fully loaded product. When it launched, it had all the global certifications it needed, and the next slide will show all the certifications it has. But basically, we're tackling Class 1, Div 1, Group C and D, Zone 0 for folks that are in the zones, and water ingress protection IP67 for the device. Again, mentioned that we are communicating LoRa. It's a LoRa. It's considered, the device itself is considered a LoRaWAN Class A device. So a very basic LoRa device that only sends data out right now. 2.4 gigahertz Bluetooth low energy is the way to communicate for configuration and troubleshooting purposes, actually. And actually a little bit more. The Bluetooth app does have a really cool feature in it that I'm going to discuss here shortly. Battery life. So you asked about battery life, right? So battery life, what we're claiming with the battery, 30-minute updates to the LoRa protocol, 5 years is what you're going to get, okay? Installation. We've tried to make installation as easy as possible. If you look at the screen, this little adapter here is a magnetic adapter. So, we're trying several things. I'm not saying these are the only options that would be available, but we've launched with 3 initial options for adapting to mounting needs in field. So this adapter here is a magnetic adapter for, you can mount it really quick on the asset that way. There's a threaded adapter, which basically just has a hole right here. So if you had a drill and tapped area on the asset, you could drive a screw through the adapter and secure the device that way, or you could have an industrial adhesive adapter. So we tried to make it easy as possible to install.
There was a follow-up question on the battery life. So,
yes.
So if I put it on the shelf in a stores situation and it sits there, is the battery running, or how do I turn it on and off?
Yeah, currently the battery is running, but you can turn the LoRa protocol off, right? But it's running in a very low rate of Bluetooth, low energy Bluetooth. So which is a very slow rate. I would expect it could sit on the shelf and you would still be well within. You could sit on the shelf for a year and you still be well within 90% of the unit with the LoRa protocol turned off. But it is always on. The battery currently for this version of the design is not rechargeable. So the idea is, 5 years, you're generally going to get your money's worth in 5 years for this device. Actually throw away right now. We're working on some other things that may transpire further down the line, where we may do a buyback agreement to where we can maybe replace the batteries. But right now, we're not claiming that these are replaceable in field unless something else, triggers something. But right now, calling it a throwaway, should last you a good 5 years, anywhere between 2 to 5 years, depending on update rates and stuff. But 5 years is what we're going with because of the 30-minute update rate.
And that update
rate is configurable. You can, yeah.
That's what I wanted to add.
It's configurable. It's not a fixed rate. So what's the fastest I'm going to recommend? Again, remember these are instruments or assets running in their normal mode. You don't need to know anything about them every second of every day. So hence, you can drive the output down to 2-minute updates. You're not going to get anywhere close to 5 years to that point. The way I have my demo running is I'm updating to the LoRa protocol every 4 minutes right now, and I have steadily watched its battery life kind of come down. So it's definitely not intended for that kind of update. It's not for your critical devices. It's for learning over time about the asset in its normal mode and being triggered when it's gone past a certain frequency range or an alarm setting that you've set within the device. So getting into the Bluetooth app. Well, actually, one more slide on the global certifications. So we've already launched, this device. So it has CSA, CSA US, ATEX, IECX, UKCA, you name it. We have the global certifications needed for this device. We have all the FCC radio type of certifications that you're going to need for a device like this. So FCC, CE, IC for Canada. And then this is Honeywell's first LoRaWAN certified device. So if you guys are familiar with, let's just throw it out there, the HART protocol. HART Foundation was, a nonprofit organization, and so is the LoRaWAN Alliance. So we're a part of that alliance, and we actually have one of the Honeywell's first LoRaWAN certified devices. We're Bluetooth certified, and we've put ourselves through our own rigorous cybersecurity certification as well. All of our any device that has any software in it that's being launched now must go through our own cybersecurity.
OIS, I had another question come through. Again, I'm not sure if it's the right time, but how often do the sensors need to be recalibrated?
Good question. They don't. They are, as they're turning off and turning back on internally, there is a self recal going on. That you really don't need. There's no wear and tear within these particular products, so there's nothing you're going to do to it to recal it, basically. So diving right into the Bluetooth app, just a quick screenshot on it. This is where you can set your tag information, link it to the asset you have it mounted on, provide details of the asset, the RPMs, the power rating of the asset. This is where you can pick your sensor parameters that you want to activate or deactivate, the units that you want to view or transmit, temperature being an example, Celsius or Fahrenheit. This is where you can set your alarm configuration if you have an idea of where your alarm should be. If you don't have an idea, by simply letting the Bluetooth app know that this is my RPM and this is my power rating of this asset. Remember I told you that we have kind of pre-programmed those basic ISO standards in. So at minimum, it will at least send those flags out. Letting you know that, hey, you're in a good range, you're in a restricted range, or you're in a you're causing damage to the device range. So at least at a minimum, if you knew nothing about your asset, those would go on. And as you build more data from the device, as you get more data and you learn more about the device, you can go back to the device and set alarms within it as well. GPS location coordinates, so you can actually take pictures of where you mount the device in field and load it into the Bluetooth app as well. And then the LoRa communication security keys. So it is, I believe the protocol is called AES 256 encryption. So it is security encrypted. Your data is security encrypted. Data visualization. So what can you see? This is a good example. You can see all 6 parameters that the device is measuring at once. And then you can get historical trends. And then you could, if you wanted to drill down and actually see the frequency spectrum of a particular access, you can actually do that as well, all from the Bluetooth app. And the alarms, these readings, they're blue now. If there was an alarm triggered, it would go red. Just let you know that you've triggered past whatever alarm was set. And you can download the time domain data. So one thing I do want to be very clear about, what we're not sending out through LoRa. And I think it is very important, because we are going to evolve to that point very quickly here. By this September, we should have a solution to this. We are not sending out the frequency spectrum over LoRa. Why? LoRa protocol has a limit to the amount of data you can send, data packet size. So if anyone knows anything about the frequency spectrum or the time domain spectrum, that's a lot of data. And you get, this is a low power, trying to save as much battery as we can. So we're not sending that data out. So what are we sending out? We're actually sending out the min-max RMS values of velocity and min-max RMS values of acceleration in Gs. So that's the, and I'll show you what that data looks like on our EHM solution towards the end of the presentation.
Always that the frequency data, time domain data is available in that Bluetooth app. So if they have a current walk around program that they're doing right now, where they have an accelerometer on a machine with a handheld, this is kind of the next step of having a permanent device on that machine and being able to analyze it with a phone, tablet, whatever it may be.
Gentlemen, I did have another
Correct. This data is available on the Blue. Go ahead, please.
Sorry to interrupt. I did have another question, and it might back us up just a bit. I'm going to ask the question as it was written. Does the sensor use site Wi-Fi to get data to the gateway? Question. If not, is there a physical wireless gateway?
There's a physical wireless gateway, and it's communicating, the device is communicating to the gateway via LoRa protocol, the long-range wireless protocol. It's not, I wouldn't call it Wi-Fi.
It's not Wi-Fi.
So what is LoRa? What is it? Yeah, so what is the frequency range? Forgive me, let me go into detail on the LoRa protocol. What is it? It's the free license band in every region in the world. So here in the US, 915 megahertz. Okay, so, and again, it's not a new technology or anything like that. Just some folks are familiar with this, some folks aren't, but it is a protocol that is almost targeting all IoT devices because of its range and its low battery consumption. A real world example. So, we thought the best place to actually utilize this, most folks want to think, control. They want to get into control immediately. This won't be the product that gets you into control. You want to tackle generally, it's going to be your maintenance engineers, your reliability engineers in a facility who are trying to keep their assets up and running. So one good example is the actual plant in India that actually makes our pressure transmitters, Honeywell's pressure transmitters. Well, they did an analysis of that building, and they found about 20 assets, rotating assets, pumps, motors, compressors, fans, blowers. So they made that a pilot site. So, they launched a bunch of devices on those products. And a real world example here is of a motor with a centrifugal pump. They had mounted a device on, they were getting readings. They probably downloaded this from the Bluetooth app, is what it looks like to me. And they were getting readings, spikes on vibration and acoustics, acoustic levels. And so, they didn't look normal to them. So they went and checked the device out, and they saw that the pump wasn't pumping any liquid because there was no liquid to pump. So on the verge of possible cavitation. So, they did what they had to fix it. Whatever they did, they didn't provide those details exactly. But after they fixed it, as you can see, the spikes calm down and it gets back into a normal range of operation. So it did kind of prove itself out to the facility. Once this project was kind of handed over to operations, this is what they were able to do with it.
And without that data, they would have ran to failure, most likely. And then with lead times now, you're out of pump for a few days. What does that mean for your output of our transmitters. So it's
Yeah.
very, very powerful.
So looking at a big roadmap, and again, this is looking 10,000 feet above. What was the intention of this device? Why did we call it the Versatilis transmitter? Because this is just one of the phases of this version, or one of the versions of this device that you're seeing, the equipment health monitor. We have launched with vibration, acoustics, temperature, humidity, and pressure, ambient pressure. But there is a list of about 28 various measurements that future Versatilis transmitters are going to be able to measure. One that I did not talk about is methane, and I specifically didn't talk about it because I don't believe it's ready for our PMC group yet. And we'll probably be doing another one of these webinars once I believe it is ready for the PMC group. But there's plenty of gases we want to measure. There's plenty of, we want to home in on our acoustics. We're actually going to make that better for steam traps. And to give you a quick insight, we're actually looking to measure inline pressure and inline temperature. So actual process pressure and temperature with the version of this device. So that'll be coming, hopefully by this time next year, we'll be talking about that unit. Again, mentioned that we launched with LoRa and Bluetooth. 5G has been thrown out. So meaning they're exploring 5G communication, meaning if you take the LoRa protocol out, 5G would be your other method of how it would transmit data. So that's being explored as well. And energy harvesting is also going to come in the near future. I'm hoping, again, same time next year, maybe we're talking about a version of this product that already has energy harvesting in it. As I mentioned, it's a lithium primary battery. It's not rechargeable right now. So what they're working on is a design, from what I've seen from the technology group. They're going to keep the lithium battery within the device, but they're going to be using energy harvesting, and they have another a way of actually generating energy and powering the device with that. And while that energy generation is going on, that's how the device will work. And when that energy generation is not sufficient enough, the primary lithium battery will take over. That's the approach they're taking right now. And they're looking into piezoelectric energy generation and photoelectric or solar power initially. All the others are also being explored, but I think they're seeing the most benefit right now from these right now. And that, in a nutshell, is just kind of a big picture overview of this family of products that will eventually be called, all be called the Versatilis transmitters. So that's the end of the presentation. If you guys don't mind, I'd like to kind of come out of presentation mode and kind of just show you the live demo that I have. So what does my live demo look like? This is a bearing fault demonstrator. So it's just a motor with a good and bad bearing provided to us. So I took the good bearing out, put the bad bearing in, and kind of locked it in with a screw. So this device is actually, this base right here that's holding the bearing had a drill and tap there already. So I was able to use my threaded adapter, secured the threaded adapter down and screwed the device onto the threaded adapter. And that's what it'll be running here shortly when I turn it on. So the Bluetooth app. The app itself, again, is called the Honeywell Versatilis Connect, available right now on Windows and Android for devices that are version 10 or higher, and then iOS hopefully very soon. I check every day on the App Store. I haven't seen it just yet. But so running a live demo, I'm gonna let it kind of pick up the device and I'll click into it. There are some other devices here in the area for whatever reason. I think I have some other, because I'm in the demo center, so it's going to pick up other devices.
Love how that it's showing how far away they are too. So if you are working a walk around and you need to pinpoint which one you're looking at, it'll show you exactly how far.
Yeah. So my PMC CEC demo is the device that I'm paired with. The others I don't even know where they're at, and they're not necessarily, well, I take that back. They are HVT devices. So someone has something running here, some devices that are hiding from me that I cannot see. But okay, let me get back to the device itself. Just kind of show you the Bluetooth app real quick. So once you get the Bluetooth app, it'll ask for a code the very first time you pair with the device. Again, that code is provided in the manual online as you need. So sensor parameters, so sorry, this is where you put your tag numbers, your asset details, any description you want. sensor parameters. This is where you can turn them on or off. Internal measurement intervals of the device as it's taking these measurements. So I have my device for internally every 2 minutes it's taking measurements, and it's transmitting LoRa every 4 minutes. And all this is to salvage whatever battery life I can on the demo. So let's jump right into vibration. If I wanted to focus on velocity, and let's say I told the device a certain RPM and told it it's mounting, how the foundation type it's mounted on and what its power is, the device actually will pick, it'll pick the ISO standard that's most applicable based on the info that I put here when I want to set an alarm. If I don't know anything about my frequencies or anything like that, it will on its own apply the appropriate ISO standard. I won't have to go any further than that on the device. So, for the newbies, myself, I would consider myself a newbie. Nowhere, I'm not calling myself a vibration expert. I think that takes a lifelong career actually for vibration.
Sure does.
But that's where you'd make your measurements or your configuration. This is where you would set your security keys. So this is this can be chosen by the customer. We're obviously going to send the default numbers in here. Customer's choice to whatever they want to change them to. This is also where you choose your LoRa update rates and the specific region you're in with respect to the free frequency band that I talked about. And there's 2 activation modes, ABP and OTAA. OTA stands for over the air activation, and I believe off the top of my head I can't remember what ABP stands for, but ABP is a most commonly used version of that's when you're making the communication to the network, the LoRa network. Device location, this is where you can put your GPS location in and other details. And then you can take pictures and images of where the device is mounted in field, load them in here, and make any notes needed. You get a quick configuration summary, and you can send the configuration detail. You can send it to the device. The device will shut off, reboot itself with all the changes, and then come back online. And then you can monitor the live data. So as I mentioned, this was a live device, so I'll let the data come up. I'll point out a couple of things, and I'll turn my motor on. It shouldn't get too loud. Hopefully you'll still be able to hear me fairly clearly. So these are live readings from the device now. So you have your ambient surface temperatures, ambient humidity. Acoustics is what you'll see the biggest change in once I turn the motor on, and you'll see the x-axis, y-axis, and z-axis make some small jumps. So if I turn the device on, Bluetooth is going to update roughly every 15 to 30 seconds by its nature. It's just what Bluetooth, how the device communicates. And as you can see, if I was ever interested in the FFT data, I'd click one of these blocks and I can do that. Now I'll show you what that looks like. So here you're seeing the decibels change in the acoustics immediately. You're seeing the numbers kind of move up and down for the X, Y, and Z axis. Let's say I was interested in the frequency spectrum and I want to see what it looks like. So here on the X-axis, you're seeing the frequency spectrum. And if I want to toggle between the axes, I can obviously do that as well. It looks like the strongest axis is the X-axis that's being affected right now, most likely because of the way I have the device mounted. If I want to download the data, I can download it right there. If I was interested in the time series data, I can obviously do that as well. That option was available right next to it where it says raw data. That's the raw time series data. And again, it's a large file, so it'll be a CVS file. And you can also download historical trends. The device does have the capability of downloading for up to 20 days worth of data. It has that feature, unfortunately, hasn't been fully unlocked. So right now you're going to get 4 hours. If I want to download the last 4 hours, I can do that. A quick firmware update for the device is coming really soon, where you're going to be able to get days. And from what I've been told, 5-minute internal intervals, 30-minute LoRa updates, you're going to get 20 days of data that you could log. So we've had several customers who are just interested in the Bluetooth side of things. So that would be a highly valuable feature for them. So that's
So you're downloading
well.
data to your cell phone?
You could download, to your cell phone, to your tablet, if you're doing it on a tablet, and then you can email it to yourself. you know, or to send it somewhere, right? Or if you had a tablet, stick a USB in, get it off your tablet. So diagnostics, you can, you know, the sensor it's letting you know if all its parameters that it's measuring, if its sensor itself is working properly, this Bluetooth comm is okay, its LoRa communication that it's sending out, is that okay? So it gives you some basic diagnostics, and that in a nutshell is the Bluetooth app. So if I close that down and I kind of show you what, and I didn't go into too much detail in the Experion side of things, and I don't want the word Experion to fool anyone. I'm not asking you to buy necessarily the big DCS guys. It's just a VM that runs on a host machine. So basically, let me go ahead and log in. So what you can do with that VM, you know, I have one asset, one motor. I had two devices at one point. I've taken the other off, and it usually, you know, walks around with me. And then one is mounted on the motor itself. So I can drill down to the motor, and I can drill down to the devices that I had. This is the one that kind of walks around with me every now and then, so it's not going to show. And the one that I actually have mounted, I could run a quick trend on. And then you can see the trending if you want. And then if you wanted to see each value, so let's say, remember I said what data did we send with regards to vibration? Acceleration in G values on the X, Y, and Z axis, velocity on the X, Y, and Z axis, all RMS values, min max that it reads within that 4-minute interval. So if you have a 30-minute interval, it's going to be the min max that it caught in that 30-minute interval, and it will, the next 30 minutes it'll update and send you the next 30-minute interval. And then the range that it's already set for. It's going to let you know if its band alarms are okay. I didn't have any band alarms set, so I don't expect it to necessarily send me anything. But eventually what will happen, it will, I believe, either on the x-axis, this will go yellow, it will go restricted. But these are the actual parameters you can see of the device if you wanted to. Diagnostics, again, humidity, you know, whatever you're interested in. So I'm not gonna say whatever you're interested in, but these are the details. You get your average, your min-max, the range. That's what's being provided over LoRa for each particular parameter. And in a nutshell, that's the device and the solution. So this is the Experion side. We're calling it the Experion Equipment Health Monitoring. It's visualization and alarming software right now. By September of this year, we're going to be introducing analytics into it. So it's going to take that RMS value that it's caught over time and the FFT data that we're going to be able to send out, and it's going to make some analytical decisions. It's going to hopefully be somewhat prescriptive and let you know, hey, this could be your issue. It's your bearing. And then further past that, we want to be able to tell you a little later on what exactly is wrong with your bearing. So it's something that's going to build on itself over time fairly quickly. So here goes the reading. So it's been about 4 minutes. So it's letting you know that, hey, I'm in a restricted area for my x-axis and I'm in an unrestricted area. I'm still okay for my y-axis. So, you know, warnings basically is what you're getting. So that's the quick live demo, and we can open it up for a Q&A if you guys like.
Yeah, I have a question.
Go ahead.
Sure, yeah, how can the transmitter data be accessed from the LoRaWAN application server?
Yeah, so basically, let's assume you don't use our solution at all, and you are totally familiar with LoRaWAN, and you have your own LoRaWAN network and server, application server set up. We would basically provide you our device and a text file. That text file is basically, it has several names for it. Some people call it a codec file, some people call it a payload formatter file, but it's the way your network server is going to decode the data coming from the device. So, and that device, that file will be relatively readily available, and I would assume that if you're just needing that file from us at that point, you know, if you're savvy enough with the network server and the application server where you can make any changes to that format file as you need to meet any coding requirements.
Yeah, but typically it would come out of the application server via MQTT protocol. Is that correct?
Yeah, if you're trying to get it off the application server.
Right.
Application server we've utilized ChirpStack, which is a popular application server. It has the ability to send it out MQTT. It also has the ability to send out in other ways that we have not necessarily utilized. I'm not saying they can't be utilized, but right now our solution is MQTT format.
Okay, and then the one question, I'm not sure if it was answered yet or not, how is the data secured?
Yeah, I believe let me pull up my little data sheet here. I had, because I didn't know the exact, so it's data security and encryption, LoRaWAN industry standard, AES 256 LoRa encryption.
Okay.
So your data is secured.
Okay, so I'm not seeing any other questions come in the chat. So what I'm gonna do is I am gonna unmute everyone for just a minute. And if anyone has any additional questions, I'm gonna give us about 15 seconds and then I'm gonna go quiet. So I'm gonna open all the mics. Okay, it doesn't look like anyone's jumped on. So I'm assuming we've been able to answer answer all the questions. So I think that's going to be it then, fellas. Vern, do you have anything to add, or are you good?
I would just add that anyone can really think outside the box with this sensor. It may not be limited to rotating equipment either. We've had some requests and we worked out some different solutions for different projects that we're working on. So with as many variables as this one sensor is bringing to us, we can do a lot of different things.
Great, awesome. Well, I think with that being said, I think we'll end the presentation.
That's a very good point. That's a very good point. Sorry, I was muted. I actually had a customer who approached me and said, I'm actually not interested in your vibration data. I like the fact that you have humidity measurement. He was interested in an area in his facility where he was getting a bunch of corrosion. So he felt like he could use the temperature readings and the humidity readings to give him an idea of what's going on. So, that's just a quick example.
Mm-hmm.
Great. All right, guys. Well, I think with that, we're going to end the presentation. Once again, thank you to everyone who joined us today. Please reach out to Lesman for any questions you may have on this product or anything else. We'll be happy to help you. So with that being said, have a great day, everyone.